is Dr. D. Govardhan, Professor and Dean, Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, we are discussing the shear factor, special cases in heat and mass transfer. The radiation of heat exchange between the two bodies generally influenced by the following factors. Three are very important. One is the temperature of the individual bodies. If the temperature of the one body is higher, the radiation emitted by that body is more than that other bodies which is having lower in temperature. That means when the temperature of the body is higher, the difference between the temperature between the two bodies more, the radiation of heat from higher temperature to lower temperature is also more. The second one is the radiation properties of the individual bodies, particularly emissivity. And third one is the orientation of the bodies related to each other. What is the direction? What is the surface directions with respect to other body? This is called here now orientation of the bodies related to each other. The effect of orientation of the bodies on radiation heat transfer is accounted by considering the factor is called configuration factor. It is also called shape factor, or sometimes it is also called V factor now. So here now the orientation of the bodies. Generally it influences the amount of heat transfer from higher body to lower temperature, but generally that can be explained by using shape factor. The configuration factor, or it is also called shape factor. Let us consider body 1. Here now, one is there, which is emitting radiations from its bottom surface, and part of this radiations is absorbed by the bodies 2 and 3, 4 as shown in figure. Here, when the body is exposed to higher temperature, the heat energy is emitted in all the surfaces, all the sides of the surfaces. But here you are considering the heat energy which is emitting through only bottom of the object. So here the amount of heat energy that is radiated from the bottom of the first body, it is absorbed by the body 2, 3 and 4. So the configuration factor between the body 1 and 2 is defined as the ratio of the radiation of energy received from 1 by 2 to the total energy emitted by the body 1 now. That means here we are seeking just F12, that is the here configuration factor, V factor of body 1 to 2 now. That means the energy is flowing from one object to second object. Generally it is represented F12. It is equal to the radiation of energy received from body 2 from body 1 to the total energy radiated by the body 1. So this is known as the shape factor. If F21 is representing, that is the amount of energy that is radiated from 2 to 1, because the body 2 is also having certain temperature, it is also radiated certain energy. The amount of energy received by 1 from 2 is given by F21. It is equal to radiation energy received from body 2 to 1 divided by the total energy radiated by the body here 2 now. So F21. Similarly, the configurations are the V shape factor between the body 1 and 3. Now just completed 1 and 2. Now we are taking the body 1 and 3. It is equal to the radiation energy received by the body 3 from 1 to the total energy radiated by the body 1 now. Similarly, F14 is representing the fraction of amount of energy that is received by body 4 to the total amount of energy radiated from the body 1 now. The configuration or the V factor, it depends upon the geometry or the shape of the bodies involved in the exchange of heat energy, and it is independent of surface properties and the temperature of the bodies. Here, a mathematical expression for the configuration or view or the shape factor is obtained by considering the bodies 1 and 2, exchanging heat by radiations which are maintained at two temperatures T1 and T2 as shown in figure. These two bodies are assumed to be placed at a distance of S from each other and having areas A1 and A2 respectively as shown in figure now. So, the total energy radiated from body 1 to body 2 is given by F12, that is the shape factor, from 1 to 2, that is nothing but energy is flowing from first body to second body, multiplied by A1 into sigma of T1 to the power of 4 minus T2 to the power of 4 now. So, that net energy lost by body must be equal to the net energy gained by the body 2. Now, from these equations, we can say that Q12 is equal to minus half Q21 now. Hence, from these relations, we can say that F12 into A1 into sigma T1 to the power of 4 minus T2 to the power of 4 should be equal to here F21 A2 sigma A1 here T to the power of 4 minus T1 to the power of 4 now. Here from these relations, here the negative sign here representing that is the T2 is lower than the T1 values now. So from these values, we can say that since T1 minus here T2 to the power of 4 both are the same now, the remaining factor is F12 into A1 is equal to minus half F2 to 1 A2. This equation is known as reciprocal relationship between the shape factor, which gives the explanation of the heat energy exchanged by the two bodies by the radiation process. For the shape factor or the configuration factor, other terms also used synonymously. They are angle factor, CV factor, sometimes it is also geometric shape factor. The shape factor depends upon the geometric position of the surfaces. If the surface 2 is enclosed the surface 1 completely, then the shape factor F12 it is equal to 1 now. Because just earlier now we discussed the shape factor depends upon the here now the distance, that is the shape, geometric shape of the objects. But in this case, the shape factor depends upon the geometric position also. If the surface 2 enclose the surface 1 now, that is in this case, the shape factor is equal to 1 now. If the two surfaces are not visible from each other, that is they are separated by larger distance, then the shape factor is equal to F12 is equal to 0. The shape factor depends upon the distance between the surfaces and the area of the surfaces. Two coaxial circular discs facing each other will have higher value of shape factor if these are moved nearer to each other. For same central distance, larger area of the disc, for the same central distance between the disc, the shape factor is the larger when the area of the disc is also more now. The expression for the shape factor, the total energy radiated by the body from A1 to A2 is given by the equations Q1T is equal to A1 F1 2 into EB1, where EB1 is representing that energy emitted through unit surface of the body. This is completely observed by the A2, as we are considering that A2 as the black body. Similarly, the quantity of radiated energy from A2 reaching A1 is observed by the A1 is given by the equations Q21 is equal to A2 F21 into EB2. That is, from the surfaces A1 and A2 are the same temperature, these two quantities should be equal, as no heat transfer is not possible. Hence, from these relations now, the amount of heat energy emitted by the two bodies which are at the same temperature per unit, that is air per unit area, which are both are equal, it are represented as EB1 is equal to EB2. As A1, A2 and F221 are not equal to 0, hence A1, F1, 2 is equal to A2, F2, 1. This is the relationship between the two black bodies when both are maintained at the same temperature. This theorem is known as reciprocity theorem for the shape factor, and we will use it essentially for the many situations to determine the amount of heat energy radiated. Hence, the net exchange is equal to Q is equal to, here if the two bodies are maintained at different temperatures, generally the two bodies emit the heat energy from its surfaces because of their temperature, but net energy is always flows from higher temperature to lower temperature, or the body which is possessing higher temperature to lower temperature. Hence, the net energy it is equal to given by Q12 minus of Q21, which is equal to A1 F12 EB1 minus EB2. The shape factor is equal to 1 for any surface according to the following conditions. The first condition is completely included by another surface. That is, one object is included by the another surface, another object, then the shape factor is treated as 1 now. The shape factor is also 1 for infinity parallel planes. From inner cylinder to outer cylinder of long coaxial cylinders, the shape factor is also 1 now. And inner and outer concentric space, that two spaces are there which are kept just inside it, such that they are having just a concentric space, that is under the same now. In these four cases, the shape factor is equal to 1 now. So, reciprocity theorem. The shape factor relationship together with the reciprocity theorem are used to evaluate the shape factor value in several situations. Here consider the bodies A1, A2 and A3. A1, A2 and A3 as shown in figure. The first rule is such that F31, that is the amount of energy that is radiating from 3 to 1 and 2. Here comma is nothing but the word is treated as a radiation of energy from 3 to 2 also now. 3 to 1 as well as the 3 to 2 now. That is, the energy is now flowing from third object to here first one. Similarly, the second one, the shape factor can be expressed as F31 comma 2, which is equal to the sum of the shape factor of F3 1 plus F3 2 now. This theorem is known as reciprocity theorem, which is applicable only, that is the three objects. One is represented as A1, A2, another one is A3. This is an obvious relation as energy reaching an area is the sum of the energies reaching the individual parts of the area. If there are n number of planes are there now, then we can say the shape factor I2J, I2K, L, M, N and so on, which is equal to the sum of the shape factor from the I2, J, K, L, M and so on. That means which is equal to Fij plus Fik plus Fil, Im and so on. So multiplying RHS and LHS by the equations, we got A3 F3 1 2 is equal to A3 F3 1 plus A3 F2 3. This is finally this is a conclusion from the reciprocity theorem. Okay, it can be stated as the total energy received by the area 3 from both A1 and A2 is equal to the sum of the energies received from the areas A1 and A2 separately. These relations are very useful in evaluation of shape factor for various geometries. The properties of shape factors. The shape factor is a purely function of geometric parameters. When the two bodies are radiating energy each other only, the shape factor is expressed by using the relations A1 F1 2 equal to A2 F2 1. Third, the shape factor is of a convex surface of flat surface with other surface enclosing the first is always unity. A concave surface has a shape factor with itself. The shape factor of a surface, it is denoted by F11 and F11 is equal to 0 for convex and flat surfaces. If a surface area A1 is completely enclosed by second surface of A2 and if A1 does not seek itself, then the shape factor F11 equal to 0 and F12 is equal to 1. Substitute values of F11, F12 in equation equal to 1 in equation number 1. We got A1 by A2 is equal to F2 1 now. That is shape factor from 2 to 1 now. Sixth point. If any surfaces are taking part in radiation of heat transfer, then the energy radiated by one is always intercepted by the remaining n-1 surfaces and by the surface itself also now. In that case, the equation can be written as now F11 plus F12 plus F13 is equal to, we can write it as 1 now. Similarly, for the second surface, if it is radiated energy to the remaining n-1 surfaces, the modified equation, it can be written as F21 plus F22 plus F23 plus F2n equal to 1 now. Similarly, the n1 minus surface is also radiated energy to the remaining n-1 surfaces. Then the modified equation is Fn-1 to 1, n-2 like that. It is equal to, finally we are having, it is equal to 1. In addition to the above equation, the reciprocal relationship between any two surfaces also holds true. That is the F12 into A1 is equal to F21 into A2 now. Okay, another important relation, radiation shields. Generally, the shields are used to reduce the heat radiation from one plane to another plane. Here, take this here now. Three planes are there now, which are represented here 1 and 2. The heat energy is flowing from the surface 1 to 2 because of temperature difference. Assume dash T1 is representing the temperature of the first body and T2 is representing the temperature of the second body, and assume one more surface that is kept between these two, which is decreasing the heat transfer from body 1 to body 2 by the radiation process is called the radiation shield. If the shield is placed in between the two planes as shown in figure 2, the corresponding their temperature here T1, T2 and T3. That means T1 is the first one, T3 is the last one, and the middle one the shield temperature according to this figure is T2 now. Assuming there is no temperature drop in the shield and considering the system is in steady state conditions, then the heat flow equation can be written as Q13, that is the amount of energy that is flowing from 1 to 3, it is equal to A into sigma into T1 to the power of 4 minus T to the power of 4 divided by 1 by epsilon 1 plus 1 by epsilon 3 minus 1. Here from 1 to 3 we are taking directly without the presence of shield now. If F13 to 1 is F13 equal to 1, other plates are kept parallel to each other now. Similarly, the amount of energy that is flowing from 3 to 2 equation is given by sigma into A into sigma into T3 to the power of 4 minus T2 to the power of 4 divided by 1 by epsilon 3 plus 1 by epsilon 2 minus 1. For steady state conditions, the amount of energy radiated from the body 1 to 3, it should be equal to the amount of energy that is radiated from 3 to 2 position. Hence, here equating these two equations, we got T1 to the power of 4 minus T2 to the power of 4 divided by 1 by epsilon 1 plus 1 by epsilon 3 minus 1 equal to T3 to the power of 4 minus T2 to the power of 4 divided by 1 by epsilon 3 plus 1 by epsilon 2 minus 1. So from this relationship we got here now T1 to the power of 4 minus T2 to the power of 4 divided by 1 by epsilon 1 plus 1 by epsilon 3 minus 1 is equal to T3 to the power of 4 minus T2 to the power of 4 divided by 1 by epsilon 3 plus 1 by epsilon 2 minus 1. If epsilon 1, epsilon 2 and epsilon 3, if they are equal, then the modified equation is T3 to the power of 4 is equal to 1 by 2 into T1 to the power of 4 plus T2 to the power of 4. That is substituting the value of these equations. What are the values of T3? In equation Q13 we got 1 by 2 into, that is the energy flowing from Q13 equal to 1 by 2 into A into sigma T1 to the power of 4 minus T3 to the power of 4 divided by 2 by epsilon minus 1. If there is no radiation present, shield present between the plates 1 and 2, the heat energy radiated is expressed as now Q1T is equal to A into sigma T1 to the power of 4 minus T2 to the power of 4 divided by 2 by epsilon minus 1. This comparing these two equations we got Q12 with shield is equal to just half of the energy that is flowing from Q1 to now. That is in presence of shield is between the two bodies, the amount of energy that is radiated from body 1 to 2 is equal to the half of the energy that is expecting energy flows from 1 to 2 in absence of shield now. That means it means that the addition of radiation shield, the heat transfer rate is reduced to half of that without presence of radiation shield between two parallel bodies exchanging heat with each other by the radiation process. If n number of shields are present between the two radiative bodies, then the heat transfer will be expressed as from Q1 to 2, that is energy flowing from 1 to 2, is equal to 1 by n plus 1, where n is representing the number of radiation shield present between 1 and 2 into A into sigma T1 to the power of 4 minus T3 to the power of 4 divided by 2 by epsilon minus 1. These are the just important relations to determine the amount of energy that is flowing from one object to another object. So when the geometries are different, it can be determined easily by the shape factor. And also, we discussed the importance of radiation shield, which is present between the two parallel plates. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.